Welcome back to The Explainer. If you're clutching a mug right now, basically hoping for a morning miracle, well, you're in exactly the right place. Today, we're taking this fascinating, really microscopic journey into the organic chemistry of our favorite morning lifesavers, tea and coffee.
Let me ask you something I'm sure you've wondered about while staring into that mug. Why is it that your morning coffee feels like this sudden, massive jolt to the system, but a cup of tea feels more like, I don't know, a gentle, sustained focus? It's a completely different vibe, right? Well, today we're going to unpack the exact molecular mechanisms behind those very distinct feelings. As you'll see, it is all about the hidden organic chemistry swimming around right there inside your cup.
So, here is our roadmap for today. We'll start with the shared engine, caffeine. Then, how it lifts the fatigue brake. After that, we'll look at coffee's unique metabolic molecules, tea's secret to calm focus, why they feel so different, and finally, wrap up with some practical tips for daily use.
All right, let's dive right into section 1, the shared engine, caffeine.
You see, caffeine is absolutely our shared engine here, but it's really just the starting point of a much broader chemical profile. Coffee brings things like chlorogenic acids and diterpenes to the party, while tea brings L-theanine and catechins. Your morning beverage is actually a highly complex chemical soup, not just a simple caffeine delivery vehicle. So, what exactly is caffeine? Chemically speaking, it's known as 1,3,7-trimethylxanthin. It's what we call an amphipathic purine alkaloid. Now, what does amphipathic actually mean for you and your morning energy? Well, it means this molecule has both water-loving and fat-loving properties. Because it lacks an ionizable proton, it easily dissolves in water and in lipids. This incredibly versatile structure allows it to freely cross all biological membranes. Basically, it gets a VIP all-access pass straight across your blood-brain barrier and right into your nervous system.
Which brings us to section 2, lifting the fatigue brake.
To really understand caffeine, we first have to understand adenosine. Adenosine is a purine nucleoside that acts as your body's natural tiredness chemical. Think of it like a biochemical timer. As your neurons work throughout the day, they burn energy in the form of ATP. And when that ATP hydrolyzes, extracellular adenosine levels start to rise. So the more you think, move, and just go about your day, the more adenosine builds up. It binds to receptors and literally presses down on your brain's sleep pedal, making you feel increasingly drowsy.
Let's actually walk through this mechanism step by step. Step 1, ATP hydrolyzes during wakefulness. Step 2, extracellular adenosine rises, sending that I'm tired signal. Step 3 is really where the magic happens. Caffeine steps in. Because its structure is geometrically so similar to adenosine, caffeine acts like a sneaky molecular imposter. It binds to your brain's A1 and A2A receptors, occupying them without actually activating them. And step 4, with the adenosine brake literally blocked from doing its job, your dopamine and norepinephrine levels increase. The big takeaway here? Caffeine doesn't create new energy. No way. It simply hides the fatigue signal from your brain.
Moving on to section 3, coffee's unique metabolic molecules. These are the compounds that make coffee, well, coffee. First up, we've got chlorogenic acid. This compound actually slows glucose absorption and raises GLP-1, which can help improve insulin sensitivity. Pretty cool, right? Then we have trigonelline. This one is fascinating. It's essentially methylated vitamin B3 and acts as an NAD+ precursor, meaning it directly feeds your cellular energy machinery. And lastly, cafestol and cahiol. These are diterpenes found in coffee oil. While they are anti-inflammatory, they also raise LDL cholesterol. This beautifully shows how coffee uniquely shifts your cellular metabolism toward fat oxidation and alters your metabolic state way beyond just that initial caffeine buzz. Now let's flip the script. Section 4, tea's secret to calm focus. Meet L-theanine. This is tea's built-in molecular peacekeeper. It's a non-protein amino acid that is almost uniquely abundant in tea, and what it does to the brain is just remarkable. It increases alpha brainwaves, which are the electrical signature of relaxed wakefulness, and it boosts inhibitory GABA, along with dopamine and serotonin. So it gently turns down the volume on excitatory signaling without causing any drowsiness at all. It's basically the ultimate natural buffer against the caffeine jitters.
But the organic chemistry of tea doesn't stop there.
Green tea contains catechins, like ECGC, which inhibit an enzyme called COMT. This actually prolongs the fat-burning signals of norepinephrine and activates AMPK for enhanced fat oxidation. So it works synergistically with caffeine to increase your 24-hour energy expenditure. Now, if you're a black tea drinker, you're getting the theoflavins and theorubigins, which give it that really brisk, deep flavor. Tea even contains trace amounts of theobromine. Yeah, that's the molecule famous in chocolate, which acts as a mild, longer-acting stimulant.
All right, Section 5. Why they feel so different.
Look at the stark difference here in the raw, unadulterated dosage. An 8-ounce cup of drip coffee packs a heavy hit of roughly 95 to 200 milligrams of caffeine. Contrast that with black tea, sitting at 40 to 70 milligrams, or green tea, all the way down at 20 to 45 milligrams. So right out of the gate, coffee is delivering a massive molecular payload compared to tea.
But it's not just the raw amount, it's the speed of absorption. Coffee's caffeine is highly lipid-soluble and absorbs incredibly quickly, giving you that immediate sharp jolt. Tea, however, contains tannins. These tannins actually physically bind to the caffeine, delaying its release into your system. So with tea, you're getting a much slower, timed release effect.
Then we have to factor in our peacekeeper molecule. With tea, L-theanine is present to actively buffer those jitters and boost those calm alpha waves. It directly counters the massive adrenaline and cortisol surges that a high dose of unbuffered caffeine can provoke. Coffee, on the flip side, has absolutely no L-theanine in it to blunt that sympathetic nervous system surge.
So, what happens when it all inevitably wears off? Well, because coffee delivers this massive, fast-absorbing dose with no buffer, the eventual unblocking of those adenosine receptors results in a steep, heavy rebound. You know the feeling, that harsh crash. Tea, thanks to its lower dose, its tannin delays absorption, and that L-theanine buffer, provides a much milder, gentler arc right back down to baseline.
Let's wrap things up with Section 6, Practical Tips for Daily Use.
Here are your key takeaways to implement tomorrow morning. First, the nootropic stack. For calm, sustained focus, like if you're studying or doing deep work, try using a 2-to-1 ratio of L-theanine to caffeine. Second, brewing. If you drink a lot of coffee, definitely use paper filters. This simple act removes those diterpenes that raise your LDL cholesterol. Third, timing. Caffeine has a 4 to 5 hour half-life. Do your brain a huge favor and cut your intake 6 to 8 hours before bed so you don't disrupt your natural adenosine sleep cycle. And finally, genetics. If you happen to be a slow CYP1A2 metabolizer, meaning caffeine gives you lasting anxiety, do yourself a favor and lean towards tea or decaf coffee to better match your specific biology. Before we officially wrap up, I really want to remind you of this mind-bending core concept just to firmly cement your understanding of the pharmacology here. Caffeine doesn't create energy, it is a molecular imposter that lifts the fatigue brake. The energy you feel is largely perceptual. You are literally just temporarily hiding your own tiredness from yourself.
So, since the energy you feel is just an illusion, are you actually matching the right molecule to your daily needs? Are you reaching for a massive, unbuffered dopamine jolt from coffee when you maybe just need a gentle, focused lift from tea? Think about that during your next morning ritual. Thank you so much for joining me on this explainer, and keep learning.